right, so for number 3 on page 89 of the homework for the week of February 18th, I am not going to go through all of these problems using the standard algorithm, but I am going to go through a couple of different things that we covered last week in class that I just want to make sure everyone has access to in case they need to at any point review. So the two things that I'm going to go over are how we use the Bowtie method to help us fill in the standard algorithm, and also how to use the standard algorithm when you have one of these questions, a 3-digit by 2-digit multiplication problem. A lot of us are very comfortable with our 2-digit by 2-digit multiplication problems, but I saw some friends on the post assessment who were having trouble with the 3-digit by 2-digit, so I just wanted to go over that. I will be going over that first. So let's solve 256 times 33. So in the standard algorithm, I'm going to start in my bottom right. With my bottom right digit in my ones place, I'm going to multiply 3 times 6, and I know that that's 18. Since 18 is a 2-digit number, I'm going to bring down what's in my ones place and carry what's in my tens place. Now I'm going to do 3 times 5 is 15. I have to add the one that I carried to get 16. I'm going to bring down what's in my ones place and once again carry what's in my tens place. And then I'm going to do 3 times 2, which is 6, and add my 1, which is 7. Then, since I've done all of my ones place multiplication by everything on the top, I'm going to move on to what's in my tens place on the bottom there, but first I have to add a 0. Once I add a 0, I can do, or actually I should probably get rid of all this junk up at the top first before I go any further. I'm going to do 3 times 6 is 18, carry the 1. 3 times 5 is 15, plus 1 is 16, carry the 1 again, and then 3 times 2 is 6, plus 1 is 7. So I'm going to add those together now that I've multiplied my 30 on the bottom by everything on the top. I'm going to add those together and get my answer. So with the 3-digit by 2-digit, it works the same. You just have to keep carrying over an extra place value. It's not too bad. To do this in the Bowtie method, what I would do is I would start and I would say I'm going to multiply what's in my ones place and my bottom number by everything in all my different digits in my top number. So if I can move this out of my way, I'm going to do 3 times 6, 3 times 50, and 3 times 200. And I'm going to find the answers to those. So 18, 150, and 600. Once I get those numbers, I'm going to add them all up. I would get 768, and I can use that to fill in the top line of my multiplication problem to make it look like I'm doing the standard algorithm. You'll see that it's the same number that we got when we did the standard algorithm, but I don't have the carried ones up here because I didn't do any of that carrying in the standard algorithm. So once I've multiplied everything on the top by what's in my ones place, I'm going to do basically the same thing that we do in the standard algorithm, where I multiply everything on top by what's in my tens place. So I'm going to do 30 times 6, 30 times 50, and 30 times 200, and I'm going to get those answers. Goodness gracious. Thinking about my base facts. 1, 2, 3 zeros. Yep. And I will add those together to get my second line, just like what we did in the standard algorithm, but once again without the carrying. So once I get those two numbers, I can add them together and get the same answer that I got when I did the standard algorithm, just a little bit differently. What we want to make sure that we pay attention to when we do the Bowtie method is place value. So standard algorithm makes it so we don't have to think about place value, but when we do the Bowtie method, we absolutely do have to think about place value.